In this question, it is given that a particle travels with a speed of 50 meter per second from the point that is 3 minus 3 in a direction, that is 7 I cap minus 24 j cap. Find the position vector after 3 seconds. So over here, first we can find out what about our velocity vector. Velocity vector is v into v cap. So the value of magnitude of speed, which is magnitude of velocity, which is known as speed, which is given as something but 50, and the direction is given by a different vector. So we can find out what about the unit vector along the direction. So this v cap can be written as the direction is given as 7 I cap minus 24 j cap divided by its magnitude. So the magnitude of, because we need a unit vector is a vector divided by its own magnitude, and its magnitude is going to be 7 square plus 24 square. So if you are calculating the value of 7 square plus 24 square, you will get a 625. Root of 625 is nothing but 25. So we'll get it as nothing but a unit vector along the direction is 7 I cap minus 24 j cap divided by 25. So we can find out what is our velocity vector. So velocity vector is v into v cap. The value of v is 50 and the value of v cap is 7 I cap minus 24 j cap divided by 25. So if you are cancelling this 25 and this 50, you are going to get the answer as 2. So we can write our velocity vector as 2 into 4, which is 14 I cap minus 48 j cap. This is our velocity vector. But in question, they are not asking to find out the value of velocity vector. RM is to find the position vector after 3 seconds. So we can find out how much this particle is going to move in a time of 3 seconds. So we can write velocity is equal to displacement divided by time. We can write displacement is equal to velocity into time. So what is our velocity vector, which is 14 I cap minus 48 j cap into what is our time? Time is nothing but 3. So we can write 14 into 3 that is equal to nothing but 42 I cap minus this we can take it as nothing but 144 j cap. This is our displacement vector. But in question, they are not asking the value of displacement. They are asking to find out the value of position vector. So consider that a particle was initially at a point somewhere over here, initially at point A. The initial position coordinate is given in question. Let's see what is given in question. In question, the initial position is given as 3 and minus 7. So let's say the coordinate of initial point are given as nothing but 3 and minus 7. And the, let's say after some time it's displaced by some distance. So let's say displaced by some distance, take it as S. So now the position or it reached point B. So our aim is to basically find out the position vector for point B. Let's say that is represented by RB vector, and take it as its initial position is represented by, take it as RA vector. So our aim is to find out what about the value of RB vector. Now from the vector addition principles, you can observe that RA vector plus S vector is equal to RB vector. So you can write this RB vector is equal to RA vector plus S vector. Now what is RA vector? The coordinate of point A is given, so you can write 3 I cap minus 4 j cap is RA vector, plus what is our displacement vector, which is 42 I cap minus 144 j cap. Now 42 plus 3, which we can take it as 45 I cap minus 144 plus 7, that is equal to 151 j cap. So this is our final position vector, or we can take it as our RB vector.